I watch these back sometimes. There is like such horrible screen tearing. I kind of feel. Why would I feel bad for you? I still watch them and I don't care. Have you all heard of text before?
I'm looking at some.
Text is like what you send Bay on Valentine's Day, right? See, our elders, they got each other flowers. Now you get text message, right? Okay. Do you all have text output by now, right?
Slow and badly, but yes.
That's my favorite way to do things. So, unfortunately, I have now made 4 consecutive assignments that I all regard as the coolest I've ever made. There's a huge problem with this, that I never have any idea what assignment we're currently working on, because my brain just remembers it as the cool one. Is the homework going okay? Okay. The next homework looks awesome. I'm partway done on it. You'll have to let me know if it's too hard. I don't think it will be, but there's a lot of steps. Did you get through it yet?
Well, you haven't finished it.
I haven't finished it, but you know what you have to do, right?
Really fun.
Yeah, it looks unbelievably cool. And I think it's cool enough that I actually want you to do it. So I might give you 2 weeks in case you are like trying to use an excuse to not do it. A lot of times, this is what I did with SHA2. Well, there's killer extensions on it, so it's worth doing the extensions too. Like, I have never tried to implement a perceptually uniform color space in CUDA C++, but I'm going to this week, and it's going to be awesome. And that's optional. So if you're like rolling your eyes at me right now, oh, it's listed as optional. No, you don't have to have fun. Okay. I'm at least going to look up what the current homework is so I can refer to it. No, that's the person I'm plagiarizing. Oh, yeah, you're just doing Hello World right now, right?
Yeah.
That's kind of boring. Oh, no, it's not boring because I'm making you do it from strings. Yeah,
Assuming
without strings.
that I'm going to want to print stuff when I'm debugging my operating system later, I am going ahead and trying to implement a more complete print function.
Not to worry, that's what we're doing today.
Oh, great.
Yeah. Okay, so, fun fact. I was going to completely steal these slides because I don't care about text.io at all. And that's what I thought. And then I looked at how the other person did text.io, and I hated it so much, I completely implemented my own thing. Now, this suggests, because in this class we have some students that have an affinity for working ahead, some of them may have also already come up with an alternative formulation. So be advised, here's the difference that you might experience between my formulation and your formulation if you're someone that works ahead. Mine is also bad, but in a way that I think is cool, okay? So I am not, by any means, telling you how you should do this in Rust, okay? I am telling you how I would solve this as an embedded systems problem if I were working on embedded systems and didn't want to spend the rest of my life working on something, which seemed to be the goal of the person that wrote this blog. I also have noted, and I've noted this with many things, a lot of times when you're following a Rust tutorial to do something, there seems to be people that are trying to use as many features of the Rust language as possible. There's nothing necessarily wrong with this, but I'm going to have at least one aside today referring to what I think of a limitation of this approach. Recall Calvin Deutschbein thought on the Rust programming language. It's good because of option. Okay? I gave a talk to that effect in Portland at the Pacific Northwest Software Quality Conference recently. And they said, wow, that was entertaining when I was done. No one said anything about whether my presentation was good. It was your presentation, actually. Yeah, that you keep not giving. Okay. All right. So step 1. We're going to put our thinking caps on and we're going to recall VGA text mode. You all remember VGA text mode. You write some bits, well, you write some bytes to some locations, right? I do want to begin with one aside. I was going to make slides for this, and then I was like, that seems like a lot of work. We should perhaps regard it as something very close to an anti-pattern, that you write 1 byte of text, then 1 byte of color. This should perhaps feel odd to us, and perhaps a better design choice should be that we have a text space and a color space, and They have different starting points, and then different indices in the text space and the color space correspond to the same location in the VGA text buffer. Why is that? I may want to block write color, and I may want to block write text, right? Especially when we're working at such a low level as individual bytes. It is odd that we're essentially working with an array of data structures when really we just want to be writing characters for the most part. So, perhaps this seems odd to us, perhaps it seems annoying to us. It seemed at least a little bit annoying to me, but not odd. I want to motivate why this is happening. I suspect that historically the VGA text buffer was implemented using wires. And I suspect the way that you wrote to the VGA text buffer is you slung a series of bits through the wires, and those bits were spatially located in the same place in the VGA screen where you would expect the information to be conveyed. So the reason you write a letter and then a color immediately afterwards is you're just going to write a sequence of bytes along a wire. They are going to fill up some internal memory or something like that and then be rendered directly to the screen. So there's a reason to have locality. Now, okay, even if I'm doing that, I can run two wires along the array, hook one up to the color center and one up to the language center, right? But, perhaps that's less efficient, and perhaps you think your embedded systems programmers can deal with it, which we can, which we did. So fair enough. My experience, which is relatively limited working in embedded systems code, is there's a lot of times when there's things that you would theoretically separate, perhaps with a data structure, perhaps with a design pattern. You do not theoretically separate them because they are physically co-located in an actual physical device. So sometimes you just scramble all of the bits together. That's just how it works. And a great example of that is VGA text mode not really using ASCII, but using something that looks an awful lot like ASCII if you don't look at it too closely. Okay. So we have a simple way to print text to the screen. The screen is a strong term. We are printing it right now to the QEMU monitor. Dang it, I always say QEMU, and we maybe agreed on calling it something else. I'm just going to call it QEMU because that's what I always call it. We are showing text in a way other than Rust traditionally likes to show text, which Rust likes to show text with a built-in macro that supports format strings. So we are going to get that working today. We're going to use a combination of Rust built-ins and hacking to get it working a way that I found unpainful. You can even encapsulate the unsafe code if you want to, which is like nominally a good thing to do in Rust. And we're also going to have support for formatting macros, which is really nice because you might at some point want to print a number. I don't know if any of you have tried to print a number yet with your operating system. It was probably unpleasant. You've probably never wanted to write a number printer in your life. I happen to be of the opinion that writing a float printer is actually a good exercise, but I'm not going to assign it because I got a lot of negative feedback on F16, okay? Even though, once again, F16 was a super cool lab that everyone liked. Okay, so we're going to print a character to the screen in VGA mode. And we're going to do that by writing to the text buffer of the VGA hardware. What does that mean? I'm going to write to a fixed memory location. That's all it means. So we can regard this, and I want to encourage you to continue to think about this physically, and I've emphasized the physicality of this. I am throwing a byte over a wire, and how am I throwing it over the wire? First, I am telling the wire the location to which I want to write the byte, and then second, I am telling the wire the byte which I want to write. When I do these two things, somehow, in the Gestalt consciousness of my bus and my CPU and all of these things, some text will show up on a screen.
That was kind of the direction the question was going in. Since we're starting from as close to scratch as we can get, how does anything know, how does the VGA hardware area sets? How does it know that this area of the memory pushes the screen this way?
So there's some sort of internal protocol over the bus. That protocol has to pre-exist the operating system because it's used to turn on the operating system. And it's used for the operating system to find itself in memory. Right? So somehow there's some way to describe addresses across the bus. Somehow. And whatever way that is used to describe addresses across the bus, which is implemented by the motherboard, not us. So that is an electrical engineering problem. It is one level below us. One of the other things that the bus happens to be able to do is address into the VGA text buffer, right? So there just so happens to be something with a visual representation capability, some form of I/O capability. And in that way, it is no different or no more surprising than the fact there could be a hard drive or a solid-state drive hooked up that contains an operating system. It's simply now we're pushing the bytes out instead of bringing the bytes in. Okay. The VGA text buffer is ambiguously dimensional. I think you can regard it as 1 or 2 dimensional. For the graphics homework, you will regard it as 2 dimensional. In all other cases, I think you can regard it in 1 dimensional. It doesn't really matter. I have a terminal open on my computer, probably. What was this doing? All kinds of things, probably. Is this 1 dimensional or 2 dimensional? I don't know. I mean, they're strings, right? Strings don't really have dimension. And so we're going to address Intuit as a 1-dimensional array, but we are going to be cognizant, we are going to be aware that we have 25 rows and 80 columns, and this is going to cause us some amount of trouble, really consideration. It's not going to be hard to work with. And at each position, we are going to regard ourselves as having an ASCII character. The blog version took some effort to regard some characters as non-printing. My claim is if you're using my operating system and you try and print a non-printing character, that is a you problem. Like, it's not my responsibility to check what characters you're trying to print. Also, I'm the person writing my operating system, so I'm simply not going to type non-printing characters into my operating system, okay? I'm already not using floats, I'm already not using memcopy, right? So, like, you can make up your own decisions. This is the breakdown. And this is wrong, this is not true, this is a lie, but we're going to regard it as true for historical reasons. Within the VGA text buffer, on the hello homework assignment, I recommended you just use, I think, F0 or 0F coloring. This is either black on white or white on black, I think. I did that because it was relatively high contrast and was relatively easy to see. There is a lot more going on that we can work with. We can color each letter individually, and we can color individually the letter and the background of every element of our 80 by 25 character 2D array, whatever we want to call it. So every single character box on that screen is going to correspond to 2 bytes. One is the ASCII byte, and then one is the color byte. The color byte contains 2 nibs, 2 4-bit fields describing color. Have any of you seen blinking text on any of your screens ever?
Yeah.
You got blinking?
Yeah.
Okay.
Well, I've seen it in my life. I don't know if I.
Oh, in QEMU? Okay. I do not think the version of QEMU that is currently standard supports blinking.
I think I did.
I think it supports 16 colors. Okay. If it shows up, somehow document it or something. Okay. The first byte represents the character. You kind of know how characters work. I am less surprised year on year by the degree to which I see Python mentioned in firmware jobs. The first time I saw Python mentioned in a firmware job, it's like, why on earth would you use Python ever for firmware? There's a lot more usage of Python in firmware now, mostly for automation. But here's one example. Maybe I care about the ASCII codes of characters. I don't know. So I wrote like a little Python thing. Can you also just look this up on Wikipedia? Yeah. Well, there's a pitch on this, right? Which is that, am I using more electrons writing this much Python or making one URL lookup? This could be more efficient than checking a web page. Especially, I'm going to call it Jimmy. I saw Jimmy looking at an image file to figure this out once. Images are a lot of bits, folks. We're going to have an acute sense of exactly how many bits those images have pretty soon. You can also do one other thing. Do I want to do this now? Am I going to go rogue? 80 times 25 is less than 256, right? So you could just print out all of the characters in order and look at them.
I don't think it's what?
80 times 25 is more than 256. Okay, so let's see. Circmain, modvuga. Oh, so I finished this, but that's okay. So where's the VGA pointer? Is it BF?
B8000.
B8000?
Something like that? One sec.
Do I have it in here somewhere?
Yeah, B8000.
That's crazy. Okay. I want that as a mute U8, right? Okay. So, for I in 0 to, is that how you, does this look like Rust to everyone? You would tell me if this doesn't look like Rust, right?
What the fuck? What is that in decimal?
It doesn't matter. It's the first 2 bytes, or it's the first, it's how many things you can fit in a byte.
8.
Yeah. Okay. And so then what do? We write to this, we say VGA pointer plus I times 2 as mut U8 equals I. Right? Is this going to explode?
What's it supposed to do?
Oh, this is like turbo unsafe, right?
Looks good to me.
This is it needs an unsafe, right? Right here.
If we're gonna be dereferencing, yeah.
Blah! Wish I knew how to use Vim. I'm actually just doing this to seem relatable. Have you shown them how to
No, I didn't.
pin nightly? Okay.
Yeah.
Oh, I have a diverging expression, folks. And what do we do when we have a diverging expression? We loop. Because if we don't loop, my ancient nemesis, the Rust runtime, blows up your call stack, even though LLVM should know that it doesn't need to instantiate a new call stack every time.
We're not dereferencing the pointer.
There's no way single equals assignment is allowed outside of an unsafe block. Oh, wait, no. You're saying something different. You're saying this needs to be a star?
Yeah.
Okay. I agree with you.
We'll see. Might run into precedence issues.
Invalid left-hand side. Wait, no.
You're dereferencing it as a U size. not
Yep, I'm
as-
yep. Never dereference your U sizes, folks. Also, for the record, you should never use U size this way. Do I do? Okay, I need someone who knows Rust.
U8.
It's underscore, right?
That would work, yeah.
Oh, do you not need an
You
underscore?
don't need the underscore.
That's crazy.
What's it?
I have to embiggenify this. I can't tell what it is. Oh my gosh, it's so whiny.
Oh, yeah. You can make it a U size.
Yeah, so I
But
want
you
it.
have to change the I to a U8 there.
Yeah, so we do. I think this is the angle. We U size it here,
Yeah.
and then we U8 it here.
Yeah.
U8 to see it. Get it? Yeah. You hate to see it. You hate to see it. No.
That would be
Okay.
funny if I could, if I had a hope of following what you were doing.
That's okay. The computer couldn't follow either.
Watch the stream in like
It's just
0.5
it's
seconds.
yeah.
Okay. No, this makes perfect sense. Okay, I'm gonna open it again. Okay, I'm opening it. Panic handler. Let's move that. Wait, no, I yoinked it instead of depleted it. Delete. I kind of want that. Okay.
He's not here. He's actually good at Vim, unlike me.
I know. I wish I knew Vim, right? I don't know how to learn it other than teach a class. I've been teaching class.
There is the whole Vim tutor. which-
I'm not about to use Vim Tutor.
That's the problem.
Okay, so for the record, students, we would like you all to use Vim Tutor. Okay? Got that? Do you need to write that down? Okay. Okay. Okay, so folks, what's going on here? We got the VGA pointer, okay? You remember the VGA pointer? I'm going to write to the VGA pointer. Where am I going to write to the VGA pointer? I'm going to write to the first OXFF bytes of the VGA pointer. That's not true. I'm going to write to 2 times that. I'm going to write to the first 256 positions of the VGA buffer because I'm going to loop over them. What am I going to write at those positions? Well, at each position, at the ith position, I'm going to write the ith character. How am I going to do that? I'm going to take I, and I'm going to turn it into a U8. Why? This has to be 2 different types in 2 different places, because over here, I'm adding I to a location. So it has to be a U size when it's being added to a location, and it has to be a U8 when it's being written to a location. The reason for that is because U8 is not big enough to store the number of locations. Otherwise, I won't be able to write all of the things. Okay? Now, so this is the start of the text buffer plus I times 2. Why I times 2? Because every character corresponds to 2 bytes. Because I didn't turn any colors on. That's why we can't see it.
Are you trying to do the blocking thing you were talking about earlier?
No, this is different.
Okay.
I'm looking at the characters that I can print. I'm going to put some colors on. I think this one was fine. Okay. So, this line writes the ith character in the ith position. This line does some kind of color and background combination. I don't remember which one. And folks, this is definitely going to work on the first try. Oh, it's actually kind of crazy. It did work. Okay, so these are the characters you can show. People who are scared about what is going to happen next in this class will notice that I have the box drawing characters here. You see those? That should be deeply concerning to you, because that means I can force you to make a video game, right? So chat, get ready to be gamers, okay? So fun fact.
How did that work?
How did what work?
I mean, why did that display an ordered list of all the characters you're able to print?
Because you're iterating through all the ASCII possibilities of the characters that can be displayed as you iterate over each position that you can put them in.
Is that how ASCII works? Is it just a 1 to a 56 value?
Well, this isn't quite ASCII.
Yeah, this is something other than ASCII, but this is vaguely how ASCII works.
Okay.
Basically, the first byte represents a character that can be displayed, and we're just iterating through all the ones that we can display as we iterate through the places we can put them.
And we can cross-reference this, right? So we're supposed to see a capital A in position 65. Now,
Which is approximately correct.
this is 80 across, right? Approximately correct. So now, J is the 10th letter of the alphabet, which that's the only letter of the alphabet that I know its index. And I see J is 5 letters from the end of the line,
Yeah, looks about right.
which means that is an A in position 65, right?
Yeah.
Yeah. Let's check where lowercase a lives.
I think is J the only one you know the index of?
Also, why are we checking A?
Because we want to check that A is in the correct position to check if it's actually ASCII encoded.
I didn't know the ASCII encoding of J. I only knew that. I didn't know this information.
But you're looking at
No. I can't see it because it was off my screen.
it.
Very clever question. You almost got me there. Okay. Let's check what.
Little faces.
Okay.
There's cards you can view.
All right. So how do we get out of here? I'm pretty sure I do like Control Alt 2 or something. Okay. Did you all see that? Okay. Control Alt 1.
Impressive.
Control Alt 1. We see the screen. Control Alt 2. We see the QEMU monitor. And then we type quit. Okay. I'm going to demonstrate that again because I'm worried you missed it. Okay, all right. QEMU's open. It's showing me super interesting, super cool, fancy stuff, right? Control Alt 2, quit. Okay.
So, please.
All right, so I think we learned something there. Oh no, this one's still open. Oh no, this one's still open. What should I do? Okay, folks.
Wait, you had a solution right there.
No, I am having to demonstrate a solution. I'm unfortunately teaching a class right now, but I'm also live on YouTube. Any chatters in the chat? Okay, so what was I going to do? Right, you have a QEMU window open, and you're a QEMU hater, so you want to close it. No problem, just look up the current processes running on your system with Ps, and you'll see, oh look, I have a boot image? Didn't really expect to see that one, that's okay. But I have something called QEMU system x86, and it has a number. Now, folks, who's a big fan of murder? That's what I thought. Right? And if you love murder, you probably know about the kill command. So
So
we're.
the kill all command even more.
I'm not going to do that one, if that's okay with you. Okay. And I bet I can kill 22499. Oh no, that didn't work. I wonder if I can look up man kill. Okay, so you need some options or something. And anyways, the signal you want to send
Slave.
is 9.
Is there a woman kill?
Oh, man's short for manual, so there's no womanual.
Okay, that's.
Is this better or worse than the man abs incident?
The man abs incident, you say? No, I don't know how to spell abs.
There's no woman abs. Non-binary abs?
Well, it might. I don't know how to be spelled.
Oh, okay.
I can't spell abs. Okay. You could. I'm sure you could alias man to woman on your system if you want.
Okay, yeah, maybe I will.
And probably if you don't do that, you're not a feminist, and you'll go to hell. Okay. If hell's real. But okay, hear me out. This is unrelated. If hell weren't real, how did Dante get all of that information about the Inferno? Right. Right. There's a lot of oddly specific passages in there. Right. Okay. So, anyways, we're doing some murder, and specifically we looked up, and you have to say kill -9. That 9 is named after the music ensemble Tech 9, so that's how you remember it, because we're working with technology. And then I think it was like 24 or something like that. No, okay. P's a 2, 4. Oh, there's a 4 here. Oh, yeah. You see it?
That's cool.
Wow.
You're all cheering for murder right now. I want you to know that. Okay. Where were we? Oh, that's not actually ASCII. By the way, you probably noticed that wasn't ASCII because it had box drawing characters, which ASCII doesn't have. Apparently, according to the blog, which I don't believe, it's called Code Page 437. And then I looked it up and I was like, ooh, I do kind of believe that because that's exactly what I just saw, right?
Yeah.
Okay, I heard the sound if you're not believing me. That's no problem. Trust but verify. Okay, all right. Like, see this?
Yeah. Yes. That's what.
That's it's pretty similar looking, folks.
Yeah, the color's wrong, but yeah.
The what's wrong?
Oh, you're
Yeah, but I programmed the color. Okay, not to worry.
You're black and white, not white and black.
Actually, I think it's light gray on plaid.
Okay then.
I have some pretty interesting things in my
That's actually
page.
true. It's the light black color, isn't it?
It's light black.
Folks,
No, it's like gray. Yeah.
better?
Yeah.
Okay.
Alright, great.
It's not formatted the same way though.
The little faces were
Okay, where do we have to line break?
in Super Mario.
I have no idea where that is. Is it? Wait, okay, so
Consider we don't actually have to line break, and I just said that.
why are you trying to get me? Okay.
It's too easy.
Don't get nerd sniped.
Okay, how easy is it?
Don't get nerd sniped.
No, I'm not saying that's easy.
Okay. I have a plan. We're going to do another addition. We're going to add I%20. Is that right? No, divide 20 times 80 or something? This was Jimmy's idea. You all should know how to do this stuff. You should be doing this for fun all the time. This is what I've been doing for fun my whole life. That's not true. I was cool once. That's not true either. Actually, just don't worry about it. Unexpected closing kilometer. Really? Oh. I don't need this one? Oh, that's not what I wanted
in
at
a
all.
sense, it works.
I like it.
Oh, I'd also have to like divide or something.
Yeah.
I have to use both. Okay. Can I just put 60? If I put 60 there, is it just going to work? It's going to be really close, right? Okay, that's not close. Anyways, as an exercise for the interested student, figure this out. Wait, I almost hit the X. That's cheating. Control Alt 2. Quit. P's. Oh, there's still one. Kill 9. Named after Tech 9. Music ensemble. Do you kids these days know about Tech 9?
I've never heard that.
What is that?
It sounds familiar.
I'm not going to look up Tech 9 in class. Students, as your homework assignment, after you figure out how to do whatever it was I was trying to do, listen to one Tech 9 music video while your roommate is not around. Okay. What is code page 437? It's basically IBM ASCII. No one cares. The second byte defines how the character is displayed. The second byte is bifurcated into 2 bytes. The same thing happened to the second byte that happened to my ancestral homeland, Yugoslavia. The Americans broke it into pieces so it couldn't be as powerful, right? And that's what IBM did to the second byte of the VGA text buffer. They broke it into pieces so you couldn't address as many colors. Specifically, they broke it into 4 bytes each for the background color and the foreground color. Okay? There's some vicious liars out there on the internet. And some of them claim that you can make text blink in your QEMU emulator. Now, the way they do that is they claim, follow with me, first 4 bits determine the foreground color. Okay. Remember this line here? What is that?
Or first 4 bits.
That's the first 4 bits, right? So we set that to F. If I say F's in chat, is that cool? Is it still cool if I say that? Okay, so we put some F's in chat. And so that set the first 4 bits to a no. I'm gonna stop. I'm gonna stop filling with this. I can stop anytime I want, and I want to stop right now, so I'm going to. Okay. Okay. So this was the first 4 bits. But what I'm actually going to do here is I'm going to just do 2 different values. And what are values that are relatively different? Can I do binary in Rust, Jimmy?
Yeah, it's like
Okay.
0B.
Yeah.
Binary.
Okay. So I put in a variety of different bits at different locations. No.
Just like killing too much.
I asked you if you liked murder, and you all said yes.
It's the Joker.
We live in a society. Okay. Something about scars. Okay, so what's going on here? Oh, Control 2. Wait. Quit. So, no matter which way you slice it, I am setting the last bit, because even if this is going in backwards, I'm setting the last bit. And I didn't see any blinking. Did y'all see any blinking? The only thing I saw was the Joker, right? And the Joker never blinks. That might be true.
I don't think
Any Batman lore masters?
I don't think any
Why
particular
would he
reference is
not
made
blink?
to whether he does or does not blink. They have to assume he does.
I've never seen the Joker blink in a comic. Okay, so the Joker doesn't blink. I did not see any blinking. And if I didn't see it, it didn't happen. I'm going to disprove the existence of some things. Do any of you believe in unicorns? I've never seen one. They don't exist. Okay? What are some other things we don't want to exist? Has anyone seen a cool ska band? Wait, no, that might offend someone. You know, trumpet. Yeah. It can't be cool if there's brass. Okay. So, anyways, I can fiddle with those bits. The first 4 bits I fiddle with change the foreground color. The next 4 bits I change fiddle with the background color. Oh, you don't believe me? I heard you not believing me. I heard the sound of me not being believed. I hear that sound often. I'm beginning to suspect it's actually me that's making that sound. I'm going to change some of the last 4 bits and not some of the first 4 bits and see what changes about the thing that I saw. Ready? Okay, I'm going to put a 1 here. No! What I meant was, I meant to do that. Oh, I think that only changed the foreground color. And I think it changed it from bright to dim. Control-2, quit. Winners never quit and quitters never win. So, not to worry, I have an answer key for you. Now, I've been widely regarded as being exceedingly obnoxious, even for the type of person I am, which is why I used octal on this slide. Why did I use octal? Because it's not actually 4 bits encoding unique colors. It's 3 bits encoding 8 unique colors and a brightness bit that measures how bright things are. So if 0, 0 is black, and I don't think it's black, I just think it's like super dark gray. This is octal 0, 0, so this last 0 refers to 3 bits, which is why it increases up to 7 and then rolls over to 0. So if I set the 4th bit, I increase the brightness. This is true on both the foreground and the background. What was that?
True on both the foreground and the background.
I heard the sound of disbelief. It's a sound I hear often. I'm accustomed to it. So I'm going to get rid of this 1 and replace it with a 0, and that's going to cause my background to be less bright. And I'm going to place a 1 here, which is going to cause my foreground to become more bright. By golly, that's a relatively bright foreground and a relatively dark background, would you not say?
It's a light foreground, right? Yeah.
Yeah, white is comparatively bright to dark gray. Okay. Wow, I sure wish I remembered how to exit this. I wonder if it's Control-Alt-2 quit. Okay. Bit 4 is the bright bit. Okay. Jimmy and I both basically agree memory mapped I/O is good. We differ in whether we think it's Rust-like, I think. To me, it seemed odd to use this in Rust because Rust seems to not want you to think memory corresponds to numbers, is my sense. Does that seem true? Okay.
Not unsafe.
Yeah, I guess. It is, yeah, perhaps it's just inherently unsafe. That's fine. And memory mapped I/O is like what unsafe is for. Like you write a byte somewhere, you don't really know what's going to happen. So there's a few ways to deal with I/O. And so right now we're going to imagine a form that isn't cool. So we're thinking uncool. We're thinking what are some things that are uncool? Baseball? Any baseball players? Do you play baseball? Okay. Yeah, I saw you react. Okay. Baseball not cool because it's old. It's going to make fun of the Europeans. They have the Olympics right now. Elton John, probably not cool anymore.
Elton John's cool.
Elton John's still cool? Okay. So imagine an uncool version of Elton John. That would be uncool, right? Okay. And so just like I/O and Elton John, there's uncool versions of things. So what does this mean for I/O? Well, thus far, we have only thought of a single memory space. What do I mean by only having a single memory space? When I just slap a borderline random number in my circ main, it doesn't matter what I cast that as. It will always refer to the VGA text buffer. I can't, well, I can because I can store memory in there. But no matter what I write there, it will always be directed to the VGA text buffer. There are not two different memory spaces that have two different addresses. There's not a different place to remember things and a different place to display things. This could be modeled by having a separate address bus, which I guess does like I/O stuff, and a data bus, which stores memory. So you could, for example, have a 64 memory location that is distinct from a 64 device. We can think of this as follows. Perhaps when my computer wants to know if the J key is being pressed, it looks up the 10 memory location because, as we all know, J is the 10th letter of the alphabet, so it only makes sense, right? But then it means it can't remember things in location 10 because location 10 is already being used for the J key. This isn't cool, and we know it's not cool because we already discussed a very similar concept in the Harvard versus von Neumann architecture, where you kind of want to have everything all mixing and mingling together in one address space, so you don't have to specify what kind of number you're working with. So we don't want to have two memory spaces for data and execution. We have also decided we don't want to have two memory spaces for I/O and memory. Is this going to be really sketchy and potentially complicated? Oh yeah. But is it worse than keeping track of or having the same number mean different things depending on what you look up? That's probably worse. There's also port mapped I/O, which is not cool. Okay, so here's an example of memory mapped I/O. Imagine our bootloader lives at location 0. Why wouldn't it? It's the first thing. And as we all know, first stands for 0th. The OS lives at the next available location, perhaps location 1. Then maybe, I don't know where you want to put your keyboard. I put my keyboard at location 2, the internet at location 3, and I put my monitor at location 4. This is awesome because my operating system and keyboard exist in the same address space, which means that if I start writing random bits to random locations in my computer, I can destroy both my operating system and my keyboard, and I can also write random garbage to my monitor all at the same time. There's no reason not to do that. That is an obviously cool thing to do. Now, okay, so I just wonder if you thought about this. Have you all thought about trying to write random information to your VGA text buffer yet? And then realized we don't have a way to generate random values inside our emulated system? Anyways, I thought about that.
Is there an x86 instruction for that?
Maybe. Then you have to use embedded assembly, which is banned.
Sorry.
We agreed not to do assembly, and when I started doing it in class, you stopped me. Okay. So, anyways,
Wouldn't it make sense to do assembly?
no, that's for the compilers class. I've been very clear about this. Everyone wants to learn assembly just because it's way cooler than everything else. You know what else is way cooler than everything else? Operating system. So that's what we're learning this term. Okay. You
have
can.
two cool things.
I will stream my compilers lectures next year.
Okay.
And if you have time to attend those, get a job. Okay.
Yeah.
All right.
What if I watch it on the job?
That's
Well, I'm a barista.
You're gonna be a barista? That's what I wanted to do when I graduated too. There's like so much pressure on, like when you go to grad school and you have an advisor who's had like 3 students, there's like a lot of pressure on me to like not quit my job and like try and dirtbag trail run, which is what I want to do. I found out the Colorado, sorry, this is not related to anything. The Colorado Trail is like not even 500 miles long. I could knock it out in like a week and a half, right? Like when am I supposed to take off a week and a half from work, right? You all would miss me, yeah?
About like during the summer.
See, now you're onto something, right? See, this is an obvious solution. Okay. I was also thinking, like, if I get really fast, I could do it Thursday, Friday, Saturday, Sunday between classes. That's only like,
Yeah.
And stream like while you're doing it.
obviously, yeah. I'd just be out there like with the laptop, be like, "Hey, memory mapped.io, like, turn on the bright bit." Okay. So MMIO is not real; it's fake, and that doesn't matter. We just pretend it's real, and then the code works. There's lots of things that are fake that we pretend are real, right? And a lot of them are related to the bus. So there are downsides to this, mainly that sometimes there's regions of memory that behave in unpredictable manners. So, you know, maybe you... Has anyone ever made you print out an I-32 as a string? That probably only works with some parts of memory, for example, right? Anyways, I think of MMIO as being similar to BIOS versus UEFI in the metaphor, where it's like, hey, we do it because it's fast and easy. Maybe there's more stable ways to do it for longevity, but we don't do them. Okay, now we're going to learn about x86-64 apparently. What are we going to learn about it? Oh, the VGA buffer. Okay. Any absolute geniuses in the chat? Anyone brave enough to try and write some bare metal C real quick? No one wants to... All right, thanks, Jimmy.
Works still.
Okay. So, well, I don't know. Here, we can... Is this how you write C? Does anyone remember? Does anyone know C? Is anyone watching what I'm doing? Okay.
Okay, I have bare metal C running.
Okay. If you write to that address, does a thing happen?
Yeah.
Nice. Okay, Jimmy, show everyone your computer.
This is written in C, not Rust.
Hell yeah.
It's hard to see. 1 second. I don't know
Okay.
I don't know how to make the text requirement bigger. So,
Yeah.
but this
Good job.
is written in C.
Cool. All right. Yeah, I don't know. Block write Hello World is a homework extension. I don't know if any of you looked at that yet. But you can just write chunks of memory at a time. If you do that, is it in here somewhere? I've told you all a few times that you have to turn on compiler built-ins, right?
What is that?
Cargo config.
Oh, is that? Oh, I've been getting errors that say I don't have memcopy.
Yeah, so you need these things.
No.
Now, I've been writing all of my code where I only write a single byte at a time. Not only because this is how my brain works, but also because I am trying not to use this out of spite. You shouldn't do that, that's bad. You should write good code, right? Okay. Jimmy keeps trying to make eye contact with me and I'm not falling for it. So it is okay, technically, to do memcopy. And actually, you know what? I mean, I'm teaching class today, so we might as well do this. I'm going to turn this stuff off and we're going to see what happens, okay?
You get the errors that I'm getting.
Or, wait, is there a way to, what's copy in TOML? Or comment in TOML? Is it this thing?
Yeah.
Okay. There we go. Okay, so we save that. This probably still works. Ooh, ooh! Oh, did we get it?
Yeah, this is what I'm getting.
Yeah.
Unfenced.
Right?
So you have to go into config.toml and do what? What did you do?
Oh, it's like in the slide somewhere. Hold on. Where's my search bar? It's this. Wait, that's broken?
In an aside on the lecture.
Yeah.
Okay.
If you control F future proofing in kernel, it will tell you how to fix it. But for some reason, it's rendering incorrectly, which is see, I missed my close quote. We can fix that. Surely. This is 40. Wait, how do I look for the next one? What's next? Built-ins. Mem. Okay, right. So I need a quote right here. Okay. No, okay. Course OS CD sort. It'll fix itself in a minute. Okay. So that will fix your code if you have the problem that I just showed you. And then to reiterate here live, we will look at cat cargo config, and I gained this thing, which I commented out, and that thing, which I commented out. Now, there's another way to fix this, which is you only write one bit at a time. I think if I do this, will that work? This might not explode. No, still not allowed.
Why would it not explode? It's a link time error.
Wait, what?
It's the linker error. It just can't find the memcopy symbol.
Yeah, but if it doesn't look for it, it should be fine, right?
Yeah.
Okay, but it seems like it's always looking for it.
It only did it sometimes.
It only did it
Which was
sometimes.
what made it,
We are skipping a byte. So
Yeah, I expected this to work because it's skipping a byte.
Yeah, so it's not turning into. Maybe it's the loop specifically. Yeah.
What'd I do?
You
Oh.
printed out the end of the for loop.
So this will still not work.
It's memcompare.
It's mem comparing?
It looks like it might be. Are you compiling with optimizations?
No, I mean, doing whatever the defaults are. Okay, I expected that to work. Okay, and so this is how you fix it. nvim.cargo config. Get your built-ins. Built-ins, get your built-ins here. All right, best I can do at short notice. And then that's probably what's supposed to happen. Okay. What did I break? Oh, because I'm going 0 to 1. Okay. This looks like I'm saying F you. That's not very polite. You see that? Okay. I don't mean that. I don't mean that. I mean, you're all cool and good and valid. Okay. Okay, so now we know how the VGA buffer works. I gotta check time. Okay, we've gone slightly rogue. I think everything I've said today has been useful. I do think that. So what are we gonna do? We're gonna create a must, because must and rust have the same last 3 letters. We're gonna create a Rust module to handle print and standard out. Okay. And I'm gonna create a new circ vega rurs file. Okay, we can do that. So, do I already have a Vigorose? Oh, that looks done. I hope that's saved somewhere. Okay. Oh, no, I should move that too. Okay, so let's go into circ main. Okay, so I added a mod VGA here, which is going to add the VGA module. I did that at the start of my program. I did it after no standard and no main. I think this is the convention. I don't know, I didn't check. And this is the same thing as an import statement in lesser languages. So I'm going to go ahead and save that with :W, and then I'm going to open a new file to edit. I'm going to open source vga.rs. Mine's already full, so I'm going to get rid of everything. And then we'll start working in this file. Okay, so we've added mod VGA to source main.rs. And now I'm going to start keeping track of some things. Now, what's the first thing I'm going to keep track of? When I print to my terminal, what I expect to happen is if I print first one letter and then another letter, I expect the second letter to show up after the first letter rather than overwriting it. How am I going to keep track of this? Well, I'm going to introduce another static commute. You probably all remember working with static commutes. They're sort of the same idea as globals. We used them for bus. It makes a lot of sense to use a static commute to keep track of the latest position on the screen because, after all, it is a persistent value which changes, which corresponds to something outside of the scope of Rust. It is not part of the Rust language. It is part of the physical underlying hardware. So we're going to use a static commute to model it. So I'm going to go ahead and add a static commute. I'm going to call it latest because this is the latest position I've printed in. And I'm going to store this as a U size. Now, this is moderately controversial because what I'm actually storing here is I'm not going to ever use this thing as a U size. I'm always going to use this as a star mute U8. Why is that? Because the only thing I'm ever going to write to this is going to be U8s. Because the only thing I can write to the VGA text buffer is bytes. But I'm going to be doing arithmetic on this thing. And I'm not supposed to do arithmetic on star mute U8. So I'm just going to save it as a U size. I'm going to do the arithmetic on it, and then at the last minute, I'm going to turn it to a star mute U8 and work with it in that capacity. So I'm going to keep this temporarily as a U size, and I'm going to set it equal to 0. That is initial position 0, okay? Because I haven't printed anything yet. So this is the first thing I'm going to put in my file. Now, you can do different things when you work with files, but one of the things I like to do from time to time, it's probably in here somewhere, is after I write some code, I try and get it working. I currently have a print line in here for some reason. That's odd. So I should probably be, where's the print line? Oh, that's fine. We can just nuke that. And this still works amicably. It just doesn't do anything particularly exciting at this time. Okay, so I'm now checking the current location in my whatever. Okay, so what am I going to do from there? Well, I also want to know the location to which I'm supposed to write to interact with the VGA text buffer. And we've solved this previously. It's this line right here, VGA pointer. I'm going to grab that. So I'm going to dd, take the line. Then I'm going to edit source VGA rurs. I'm going to paste that in. And then I'm now going to treat this as a constant because I'm never going to change this thing. I'm only going to statically add it to whatever U size is. So let's go ahead and do that. We're going to const. I don't know what to call this other than MMIO. You can call it like VGA buff or whatever. I'm going to call it MMIO because that's what it's called in the slides. That's going to be this value. And here I have this saved as a mute U8. I don't see any reason not to do that, right? So we'll star mute U8 this. It's not a U7. You ate to see it. You ate to see it, right? Okay. Surely that's supposed to be a you ate. You ate to see it, right? Okay. So a lot of people like having colorful text on their screens. Not me, I don't like anything. So instead of having any sort of clever way to deal with color on my screen until I get to the graphics assignment, which is looking like a really exciting assignment coming out this week. Super excited for it. I've been working on it. It's really fun. I just used the requests library in Python, right? Who loves requests? Okay. So I'm also going to just have a constant for color, and then I can change it, and it changes in every place. So we'll just have a color. It's going to be a U8. That is not how that's supposed to look. It's colon next to the variable, space, U8, space equals, space, and we'll throw an OXF in there. So I think that'll be, again, it's either white on black or black on white.
Aren't you going to want some ability to choose foreground and background colors?
No.
Okay.
You can implement that if you want.
I'm trying, it's hard.
That's not that bad. You'll do great. I trust in you. So these are things that I'm holding on to. And then what I'm going to start working on is, back in the olden days, when languages were cool, the only thing we were allowed to do is put characters on the screen. And this is referred to as building character. So some of you may have heard this before. So in the olden days, you just got to put one character at a time. And this was very nice because you just get the character. How old is this function? It is so old that characters and ints were the same size, which means this was designed on 8-bit machinery. And it just shows up on your computer somewhere. So I thought, why don't I go ahead and write this? I'm a big brain genius, so I can do whatever I want. One thing I have as a note here is that I'm going to write a series of functions inside Vigors today. Oh, I can pronounce that as Vigors. Many of these probably should not be public, but a lot of them are going to start as public. Why are they going to start as public? Because I'm going to test them. And I'm going to set them back to private as soon as I stop using them anymore. So this is not going to be permanently public, but for now it's going to be public. And I'm going to try and take a character and put it on the VGA screen. We'll call it chart of VGA. I'm going to go with the convention of the character being named A for like an alphabetical character. You could also call it C. Maybe that's kind of confusing. So I'm going to use A. A is going to be a U8 because it's a byte. And then we're not going to do anything with this yet, but we're going to throw a to-do error. Okay, I'm going to save this. And I'm going to modify my main, circ main, to test this function. So let's get rid of some of these lines. Okay. Now, in order to do this, I think I say VGA, chart of VGA. And what character do I want to print? We decided A was 65? Does that sound right? Is that a U8? I think that's fine. It's pretty annoying I have to keep typing nightly because none of the TAs will teach you how to use it. Okay. Help. Wait, there's an error? Provide a type for the constant. Oh, yeah, that's my bad. Okay, so when you have these sort of, I guess I'll call them globals. But when you have a constant, you're supposed to specify what type it is. So that's a mute U8. There we go. Works great. Oh, I guess I'm not seeing anything. That probably means I'm doing something wrong. And the thing I'm doing wrong is I haven't written the code yet, right? I have a to-do in there, okay? So we're actually going to write the code now. Now, how am I going to get out of QEMU? This is a quiz. There you go. Okay. Control. Wait, I'm still in QEMU. What do I do now? Winners never quit. Okay. So let's go ahead and write this. Okay. So what I really want to do is I want to go to location, basically MMIO plus latest. And I want that to be equal to A. And then I want MMIO plus latest plus 1 equal to color. This won't work. And this won't work because I'm sort of playing fast and loose with my types here. So I think what I need to do here is I'm going to turn this back into a usize. And then I think I'm allowed to add these things together. And then once I add them together, I'm going to turn them into mute U8s. At least that's what I think I'm going to do. I think that'll work. Use of mutable static. Oh no! I'm working with a mutable static. Mutable statics are sketchy, so I can only work with them inside unsafe blocks. That makes sense, because what we're doing is writing to an arbitrary memory location, which is one of the most dangerous things you can do. So let's go ahead and put this in an unsafe block. How am I going to do this? Now, I could manually fix this indentation, but because Jimmy left, I can show you cargo format. So I'm going to, so this indentation is bad, right? Bad, wrong, evil? Yeah, okay. Get out of there. Cargo format. Source, what am I doing? VGA. No, oh, it's not a man. Cat, source. How long is Jimmy going to be gone? I'm typing slowly because I'm nervous. Okay, see, it fixed the indentation. See that? That's cargo format for you. I'll show you it again. Cargo format. See? Look, cool. It's very cool. Okay.
How's like normal GG equals G?
GG.
Well, no, like when you're in Unit or Vim.
Wait.
Yeah.
Then I do.
And then you do normal GG equals.
Wait, what's
G.
normal?
Press the go into the other, yeah, normal.
Oh, normal. Space.
GG equals capital T. That also does it.
Oh, I see what that's doing. Okay. Oh, it's normalizing annotation. Yeah. Okay. That's very cool. Vim tips. Put it in Discord. Okay. Wait, did that work? Oh, okay, that does work. See, there's an A. And that's the grade you'll get in this class if you write an OS, which most of you have done. Okay. All right. Cool. This is how I did it. Yeah, casting MMIO back to a usize, I think that's silly. I think the way I did it just now, where I just store MMIO also as a usize, then add them together into a single cast. That makes a little more sense to me while I'm standing here in front of all of you, but you can do whatever you want. You're adults. Okay. So you compute the absolute location from relative location. You store a value at that location. You store a color at the next location. Ooh, this is not normalized. This is like the relations between the People's Republic of Korea and the United States. It's not normalized. That was good. That was a good one, right? Okay. Okay. I asked my AI class this question today. Who was president in 1986?
Carter.
Do you want to try again?
Reagan.
There you go. Good job. Okay. Oh no! I just realized I made a horrible mistake. I didn't increase latest. Why is this a problem? Here, I'm going to demonstrate why we made a mistake. Okay. What happens if I want to put one character and then another? This should say AB. It doesn't do that. I simply overwrite the A with a B. So how do I fix that? I Control-Alt-2, I quit. I am in source vigors. I need to also increase latest once I write. Then once I increase latest, once I write, then I can test and I can write. Did I not spell latest correctly? Wait, it's lowercase? Did I really make it? That's crazy.
You do.
Let's see if I remember how to do replace.
There's actually a way to just uppercase it, if that works too.
Wait, there's a way to uppercaseify it? Can
I
I?
don't remember what it is. You have
Oh.
to ask Indy.
Indy stopped coming to class.
Yeah, no, I need to bully him more.
I think Indy's not going to get. Oh, folks, we're cooked. How did we get cooked like this? We did everything right. Unless we didn't. What do you. What? Don't.
You almost clicked the X button.
Indy's not here. There's no rules. I could have been typing cargo run the entire day today. Okay. These should not actually be plus latest, because the number of characters is not how big my offset is. Every time I print something, I have to move 2 over. So we'll just multiply this by 2 real quick. And absolute geniuses will notice, folks, that's y equals mx plus b. That's 8th grade math right there. A lot of people think you don't learn anything in 8th grade that's useful for embedded systems programming. Show them this code. Right, they'll know what it means.
And they'll scream and scream and scream.
That's what 8th graders are supposed to do. AB.
Just an A/B testing.
That's exactly what it is. And then what is the next letter in the alphabet? That's right, we're going to do abs. Oh, no, I don't know what it is, so I actually can't. Okay. All right. So Jimmy once asked me, how do I print strings? And said, do you really just type in numbers as U8s? And I just wanted to know, this was not a bit. I just happened to be doing things this way, and this felt like the most natural way for me to do it. I'm not like
Should have expected.
I'm not like proud of the fact that this is the way I am, but like if this makes intuitive sense to you, you're not going to do anything else. Okay. All right. We should write a loop. Who loves loops? Okay. Let high, which is, what is this going to be? This is going to be a array of U8s. I think that's fine. And I'm supposed to use the B specifier, which is bit. I don't know how Rust works. So we're gonna make. I think this is the same thing as making an array. It's the ASCII values of those all put together. And then I'm gonna loop that. For I in. Can I check the length of this? Is there like a high dot length? I don't think there is. Okay, let's check. We're going to print all of these. And I think now I am able to index, because that's Rust knows that's an array. So I'm finally allowed to use indexes instead of casting things to uSizes, adding things to them, and then casting them back. I kind of don't want to use that, though. I'm on my best behavior today. Okay. For real? It can't find high?
Okay, you didn't use the colon for the type of incubate.
I think I did. Kind of looks like I did. Oh, hey! Folks! Control-2, quit. Okay, now, absolute geniuses will realize you didn't have to write all of that in main. You can, in fact, write a helper function that does all of this utter nonsense for you, right? So, let's do that. Don't want to do it that way? Okay. I'm gonna yoink this. Am I gonna yoink it? I'm so surprised length worked. I really didn't want it to work. I guess it doesn't matter, right? Okay, and then we're going to go to Vigors. I'm going to unpub this, and I'm going to make, whoa, that's not what I meant to do. I'm going to make a new pub fun, and this is going to be, I guess, like, string to VGA. We're going to take S, I can take just a string, right? That's fine. We'll figure out how to deal with that. And then, for I in range len of S. Now, somehow I need to get the ith character of this string. And I'm pretty sure I can't just do this. We can try it. Okay. So, why is that indented wrong? Okay. VGA, stir to VGA. And can I just put a string in here? Okay. What's going on here? String cannot be indexed by usized. Use of unresolved crate name? Did I get rid of mod VGA? That seems unlikely. It's right there. Okay. So I think that's because VGA didn't work. So instead of doing, I don't know, let's check the answer key. Oh, I just turned it into bytes. Hell yeah, that's super cool. Why can we do that? I already can't print any Unicode characters. I showed you every single character I can print, none of them are Unicode, right? So I'm just going to say they're bytes because that's how they're going to show up anyways. I don't know why I don't just live in the source directory at this point. I'm always typing source before things. So what do we do here?
You can also actually change it so that this directory that all the files live in is just where the Carcotoma was if you wanted.
I think I would find that more annoying because I often also have scripts living at top level.
Okay. That's fair.
You can show them that if you want. That feels not useful.
It depends on what kind of project it is.
Yeah. What was I going to do? Oh, we'll say b equals s dot, was it as bytes? Did anyone remember? I guess it should be b's. Why is it saying that?
It's because you're trying to access VGA from inside VGA.
I'm for real trying to access. Am I? Oh, I see this here. Yes.
Yeah.
No, that is crazy. Why would I do that? Okay, folks, never copy paste code. Just don't do it. Just always type. Wait, is this gonna work? Oh, I think that's what it was supposed to. Is that was? Let's. Okay, I'm gonna Control Z, but only once. Okay. Am I trying to print hello? Yeah, I'm trying to print hello. I printed the thing I was trying to print. Okay. Well, oh, it's still there. Oh, what do we do? This would be unsporting. There's two of them? Sorry. No, there's two of them. Okay, all right.
This is what kill all is for.
Do I really want to kill all?
Kill all boot image, kill all from the system x86, can kill both of them.
I don't know what boot image is. Am I supposed to be killing that?
I think it's just the program running that cargo spawns that doesn't end until the new ends. That's disappointing.
22499. I don't even know if I can do this. Did I get both of them? I didn't get either of them?
That seems like a problem.
Does it? Yeah, we might just be cooked. Oh, they seem gone. I bet this is fine. I don't really know what's happening, but it's probably fine. Okay. I have an opinion that Rust is bad. Okay, so hear me out. Why is there 2 bytes, as bytes, and also bytes methods? Don't ask Jimmy. Jimmy might know the answer. I got stuck for a long time using .bytes instead of .as bytes, which apparently is a different thing. So you can click at these links and you can see if there's any internal logic here that makes sense to you. But there wasn't any logic that made internal sense to me. I also couldn't figure out why my markdown was indenting this, so just don't judge me for that. And like, there's a bunch of things that also have bytes, so I don't know. Anyways, I want to point out there's something that always works. And folks, it's turning things into pointers. Just only use pointers. Never use the Rust APIs. Always use pointers. That way, when you have to use C because Rust stops working in a few years because the compiler is too complicated, everything will just work. You can just translate your C written in Rust back to C, which is an extremely cool thing to do. That's not real advice. I do just want to point out, if anything ever breaks in Rust, you can always just flip on unsafe, move the bits yourself, and it will work if you move the bits correctly. Will it be unsafe? Yeah, so there's, like, you shouldn't do this. I didn't do this. I wanted to do this, and I didn't. But you can. All right, we're printing. Okay, I bet we can print any string. I'm going to print the easiest string in the world. Well, the second easiest string in the world. I'm just going to replace that silly little space with a new line. And I bet this will work no problem. There's no way this won't work. Right here. Okay, well, I'm so sure it's going to work. What have I been typing in here? Okay. I'm just going to update main. I'm just going to put a little new line in here. I wasn't going to teach you this, but Indy got stuck on it, so it might be hard. That's not always a good metric, but we only have so many metrics. Oh no. Folks, do you see what's happening here? Do you see we have what they call a big problem. We don't have the ability to do new lines. So what do we need to do? Well, somehow we have to figure out what this character is. We have to detect that character, and then we have to correspondingly update our lines. Now, since I have, I think, 10 minutes of class left, that is going to be left as an exercise to the interested student. Right. Actually, is the rest of this left as an exercise to the interested student? I think it is. I printed Pride and Prejudice. I think this is fine. Okay, I have to give you a few remarks on volatile, and I think that's all. Okay, I'm doing something that deviates from best practice. How does it deviate from best practice? Oh, my throat is killing me. That's crazy. Are you all healthy these days? Okay. That's good. What deviates from best practice? Okay. That is a use of single equals assignment that nominally, and I don't believe this, but some people have claimed this, has no externally visible effects to the Rust compiler. What does this mean? This means if the Rust compiler is optimizing your code, it may see that assignment, believe it is not important because there's no reads from that location, and then optimize out that write because it doesn't think it's affecting anything. Which means you may never write anything at all, even though your code says to write things, because the compiler doesn't think it's important. We can imagine, for example, if I don't know, I don't know if this is like a legal expression in Rust. This is always what I use instead of pass in Python. If I put a nothing expression in here, this expression is perceived as not doing anything by the compiler, and it lets me know. So it's like, hey, warning, unused expression that must be used, but it's only a warning, so it's not forcing me to use it. And I can even suppress that with a let blank. So the compiler is definitely, it's already telling me it's going to ignore this, right? Now, it's not telling me it's going to ignore everything, but the compiler is allowed to ignore lines of code that don't seem to do anything. It is reasonable that a highly optimized compiler can look at this and say, No one's ever reading that A back out of there. Now, when you implement scrolling and so on, you will be reading A's back out of there, so you'll want to work on that. But this means that you're not supposed to use single equals assignment for this. You're supposed to use volatility. I don't think you have to use volatility. I am required to teach you that you have to use volatility because it's good practice. Do you use volatil?
Yeah, it's standard practice to use this for any MMIO.
Yeah. So that I believe it's standard practice. Like without checking, I would assume
The
you're supposed to
Linux
use
kernel
volatil.
uses it, so not necessarily directly same way as Rust, but
Yeah.
we do use it.
Okay. In my implementation, which I skipped over because I've been exceptionally long-winded today, even though I've been having a great time, I hope you've all been having a great time. I do actually read back out of the VGA buffer, so that claim doesn't actually apply here. But maybe you don't, right? Maybe you maintain your own local copy of the VGA buffer and you just block write it every time there's an update. There's nothing wrong with that. That's probably what's practically happening in memory anyways. So, if we lacked the skill and bravery of the instructor of this course, we may have a problem. Fortunately, we don't. I'm here. I'm providing my skill and bravery to you. So what we need to do is every time we write, we should be using a volatile version of write. Volatility means, I don't know, what's even the definition of volatile? Like, it intuitively makes sense to me. It's like stuff that changes a lot. Liability to change rapidly and unpredictably, especially for the worst. So you're supposed to regard memory as if it can change rapidly and unpredictably, especially for the worst. Which means, oh no, I just closed everything. We'll get it back. We'll get it back. We'll get it back. Are we going to get it back? I'm running out of minutes. Okay. So, you should use read volatile and write volatile. I found them in standard pointer and also in core pointer. Why do we care about this a lot? We don't have standard pointer. Remember, we said no standard? We have no standards at all. That's why we're happy. And also core pointer. You do have core. You remember compiling core, right? So you can use core pointer, write volatile, and read volatile. And you should use that instead of single equals assignment. Now, to me, inherently, this just looks like embedded systems code, so that's why I showed it to you looking like this. It is not best practice. And I'm guessing all I have to do... Do I just, like... There's no way this works. Is this going to work?
There's one thing you have to change to make it work.
What do I have to
It's
change?
gonna work.
Okay.
If you get rid of the reference, it should work, yeah.
Oh, yeah, because that's not important. Anyways, that's the correct way to do things. Essentially no difference at all. But now, meeting best practice, because it's preventing this problem where the compiler can look at your code and be like, I don't really think you need to do that. Okay, that's all. Formatting, cool. All right, that's all for today. Anyone have any questions? There's like a lot of stuff in the slides that may be useful to you when you're working on the lab or when you're working on the homework or when you're working on whatever. Follow it or not or do whatever you want. I'm providing it for you. Do you want me to finish this lecture on Wednesday or do you want to work?
What's the lab set for Wednesday?
I'm pretty sure it's to do what I was going to be lecturing on. It's format macros. So I'd either talk and you'd follow along or you just do it yourself while I help. Just think about it. We can decide on Wednesday. Cool. Well, I had fun today. I hope you had fun. Oh, Kimu's back.
Hey, blinking.
End stream. No, I don't end it here, right? I end it in OBS.